Not properly perhaps. Welcome, it is noon. My name is Mark. And my 20 minutes will be about giving you a little inkling of what is happening outside of Europe, North America more precisely. This is FOSDEM, this is European mostly, and I thought it would be a good idea to give you a little bit of an idea what type of geospatial trends and developments in the technical arena are happening in especially the USA. I work for the Eclipse Foundation. I'll come back to that later. When I started my own company in 2000, my own open source service provider, busily looking for a business model, it was all about what I would call traditional mapping. It was all about, where is my house, and where is my well, and where is my whatever. And it was all about, you import a file, you slice and dice a bit, and you edit maybe a bit. You try to publish it via whatever visualization tool was available at the time. And that was it, and everybody was happy. And once every week, month, a municipality would update their files, and you would load it up and slice and dice it and edit again. And that was called data management. Now, fast forward 17 years, and we are finding ourselves in what we call the era of big geospatial data. And I'm not talking millions, I'm talking trillions and more. Because if with all the sensors, satellites, and social network information that becomes available on a daily basis, and if you still believe that there's the 80-20 Pareto rule that 80% of all data has a geospatial component, then I really feel that there is an agenda for us in this room and beyond to sort of have a look in what does that mean for us in terms of the tooling that we use. Imagine you having a wearable, counting your steps in order to sort of lose weight. You have your car, and preferably it is a connected car. It's not about mapping. As far as I'm concerned, GIS 2.0, 3.0, whatever you want to call it, it's about spatial awareness in general. And the geospatial component is just part of the features, one of the many features that is sold in an end product. It's not about the map anymore. It's about the end product and the spatial awareness that that end product has. So we all know Intel inside, what is it, Coca-Cola has saccharine inside. That's a sort of ingredient branding. Personally, I think it's spatial inside from now on. And not that you're going to be out of a job anytime soon, but if you want to sort of reach your pensionable age, well, please take note. Spatial insight, well, what does it relate to? Internet of Things. Everything becomes a sensor. You become a sensor. My watch becomes a sensor. And it all sort of interacts with one another. Imagine the huge amounts of data that is being transferred, handled, has to be interpreted, has to be processed. We all drive our connected cars and maybe our autonomous cars eventually. We are going to live in smart cities where we interact with the lamppost almost, which is sort of good, because if you're drunk you don't run into it anymore. Your wearable goes off and says, sorry, you're about to bump into a lamppost, and you sort of make a little detour. Earth observation. Well, can you imagine the amount of satellites at the moment circling Earth? It's so busy up there that if we want to shoot a rocket into space, we have to find that little window of opportunity out there. reversed, all the satellites have, well, they reap so much data about our environment that it is not possible to process that with the old tooling. Okay, GeoServer on steroids can really do a lot, but also there is a finite point to it. I had to sort of look up what the V's were in big data. Well, if you see what it, if you could sort of think about what that entails for the geospatial agenda, then there is an emphasis on what I would call velocity and the visualization and the variability in particular. Volume, 80-20, okay, we're still talking about trillions more than the present 100, 200, 500 million. And when we talk about velocity, well, guys, it's really about now. We want to have the data and the interpretation almost instantly. Variety, hey, that's where we come in. If almost all data has a location, then that is true, that's valid. All other information related to that object can be untrue, but there's at least one thing true, unless we have a sort of different type of Earth in the near future. How much variety does this geospatial data, sea or ocean, entail? Well, at the end of the day, it has a place, but it has also a time tag. Something is measured at a given time. I'll come back to that later as well. Well, visualization, I think you guys are much more aware of what is possible than I will ever be. And, well, the value of it all is once you have the place of and the relative position of all those things, people, then you get relational insights from which you can deduct quite a lot of, how do you call it, value, business value, academic value, personal value. And within the Eclipse Foundation Location Tech Working Group, we have a couple of projects. I'll just sort of skim over the four major ones that I think are quite mature by now. We have had our first simultaneous release in November. I call it a semi-simultaneous release. It was November and the first week of December. But that was the first time in 2 years that we had this. Most of the projects have an age of 2-3 years at the utmost, so it's all quite new, not unlike not like GeoServer, which is around since I am working in the spatial arena. We have one, GeoMesa, and that manages up to trillions of vector data. It streams it real time, and it is all based on a cloud architecture. That's the only way to process those huge amounts of data real time. It's all distributed computing, and so it needs to have support for Cassandra, HBase and the like. I was looking for a picture of its major use case. With GeoMesa, all ships in the world's seas and oceans are tracked real time. And that is a project that, if I'm not mistaken, was initiated by the American government. Which brings me to another item. Did you know that in the United States, legislation is very strict? around the production of open source. I hope the roof will hold. What they believe in, and I miss that dearly still in Europe, and I'm running around Europe for a long time now, but in the States they say, as a governmental agency, we have to provide return on investment and of taxpayers' money. So anything that they create in terms of code needs to be open sourced. And here we have the European Union sort of trying to get legislation going and national governments. So I really feel that we are sort of lagging behind there. GRASS was up earlier, the 7.4 release. It was once donated by the Department of Defense of the US. So there's a long tradition within the US government to provide us here with tooling that we can work on and that we can help maintain and build upon. Another project, it is slightly on how. I think for 90% the same as GeoMesa, but it has different use cases. This is a bunch of libraries that help to compute in a distributed manner. And it can be in the cloud, but can also be in your own environment. It makes use of GeoServer, and again, it stores, retrieves, analyzes big geospatial data sets. Then we have the raster part of our industry. Before I was talking about vectors. This is also a tool set, and mind you, this is not a finished product. Finished products can be made on top of these tool sets. And here again, it's all about trying to get your architecture in the cloud and to make maximal use of it. One project I'm really proud of is sort of GeoGig. It is derived from the GitHub Git ID and concept, where you can handle raw geospatial data, and that allows you to have what they call spatial temporal, I never can remember that one, insights. So can you imagine you're a Red Cross volunteer and you're on site in a disaster area, and you want to know from your colleague who is about 100 meters further down, or a kilometer further down the road, is the situation there better or not? And meanwhile, somewhere in a head office of Red Cross or a project office, somebody who is far removed has to have an insight what is actually happening at and what is the state of affairs at the disaster area or in the disaster area. So their volunteers can plug in what they see. Hey, no houses, no roads, no this, no that. And they can do it real time. It's stored, it is versioned, and for, let's say, whoever is the project manager for that specific area, he or she can really have up-to-date information and see how it progresses over time, or quite often deteriorates over time. Now, you all know OSGeo, and one of the reasons why the projects of OSGeo have gained traction, have gained credibility, is because of the fact that there is a home for them. It's not something that's somewhere on GitHub. I'm from the years of SourceForge, 600,000 projects listed on SourceForge. if you wanted to find something, well, good luck. Most of those projects have died, probably by now. And SourceForge and GitHub in itself are not a home for a project. In order to have a project that is being maintained and that has a sustainable future ahead of it, you need to have management on top of it. And you can do it by totally only volunteers. That's great. And it quite often works. But somebody needs to sort of pull all the threads together and have an oversight. Well, the Eclipse Foundation does that for a lot of also non-geospatial projects. And all the projects are sort of organized around and in working groups. So we have a science working group. We have an IoT working group. Polarsys is one for system modeling. And we have location tech. That way there's a focus on, hey, how are the projects doing? And we help them develop a marketplace. Because good technology in itself is never going to win the race unless somebody is sort of willing to pull the card and say, hey, I'm going to sell it. Now this is a rather technical environment, and the moment that I use the word sales, sometimes I see people like, oh God, what's that? I don't want to have anything to do with it. But at the end of the day, your salaries need to be paid by an end user. And that's where foundations can help you. And a foundation like Eclipse and a working group like Location Tech is the place where there's not only technical development going on, but also market development. We are going to create interest with end users. We're on the road, like I'm here on the road. And if you're working for an end user, hey, maybe you could think, hey, gosh, I'll have a look into it. Or if you are part of working for a service supplier, good, great. Maybe you can become a member and help develop that market locally, internationally. That is the way to do it. The Location Tech Working Group, it has a steering committee, it has a participating membership structure. We have guest members, for those who cannot pay it, or just want to have a look, just for 1 year, what this is all about. We have also a project management committee per project. So for GeoWave, there's a project lead, and that lead is a representative in the project management committee. The same for the other projects. We have a mission, of course, and a focus, and okay, please read it. But at the end of the day, it's all about collaboration. Pre-competitive collaboration, technical collaboration. We try to focus on solutions, but also on components and tools that help you create an end solution. And we try to sort of mix with the other working groups. Like, hey, IoT, there's a geospatial component to your sensor. Maybe we can work together. So we cross-fertilize within our larger community. I mentioned quite a lot of this already. If you want to have a look at our projects and what it's all about, most of them have still a very American base to it. And what I hope is that they are going to be picked up also by the European crowd. I don't see these projects here in Europe. And maybe you can sort of rectify my opinion about this, but I'm feeling, and that was the original title of this talk, I'm feeling that Europe is going to be left behind when it comes to real big geospatial data analytics. We are dealing with millions, hundreds of millions, 500 millions. Hey, what about trillions and more? Are we prepared for that? Normally you would have a project like one of these already in Europe. I don't see it. Well, now we can create our own, or you can join what's already there and what has been already paid for. That was it. Thank you. Questions? None. Oh gosh, it was too much of a sales pitch. No, please.
When you're lagging behind with big data, you're saying, could that also be a problem or a fear of privacy and data awareness?
I think the whole fear factor is hindering us so much in innovation, because unless we can really here at this table say what are the elements that, or what are the actual fears, what do we fear? But it has become such a discussion about privacy, discussion this, discussion that. But at the end of the day, if I'm Bosch, the large German engineering company who has just joined Eclipse as a strategic member, they sell products. They have assets like cars, trucks, you name it. It's huge. They want to trace their assets. And those assets, at the end of the day, when they have sold it, like little pieces of goodies, three-dimensional mostly, then you're wearing it. I read a little tweet lately that Fitbit or whatever type of thing around your wrist, there were army bases of the United States Army, how do you call it, found out, because the military guys were running with their Fitbit all over the terrain. At the end of the day, it's not the thing that is unsafe, it's the usage. And I think it's really sad that then the usage, the particular usage of that thing is then, how do you call it, diminishing the value of that thing. And yes, you have to be absolutely careful with data in general, whether it's 1 million data sets, 100 million, 1 trillion data sets, but the same rules have to apply then. So I don't think it's a hindrance, it's more like, okay, once we get used to the hundreds of millions, then we can scale it up. Legislation is not different for 100 or 500 million. You see where I'm coming from? Anybody else? Okay.